Now, in our previous examples, we were taking our moment of force about point O. It doesn't always have to be about point O. That is, we can take our moment of force about an arbitrary point within our system, say B. And if our force is applied at point A, we can define a position vector, RAB, based upon a position vector going from point O to A, less a position vector going from O to B. And we can define R such that it's XA minus XB in the I hat direction, plus YA minus YB in the J hat direction, plus ZA minus ZB in the K hat direction. Thus, our moment of force about point B would be M sub B would be equal to RAB cross F. That is, we can take our moment of force about any point on a body of interest. Lastly, for a two-dimensional case, our force vector can be decomposed into our principal directions. That is, F is equal to F sub X I hat plus F sub Y J hat plus F sub Z K hat. If we simplify this to a two-dimensional system as shown below, F sub Z would be equal to 0. Thus, when we take our moment of force about point B, we'd have I hat, J hat, K hat populating the first row of our determinant, Rx, Ry, and 0 populating the second row of our determinant, and Fx, Fy, and 0 populating the third row of our determinant. Our I hat and J hat contributions to our moment will be equal to 0, and the remaining contribution is only going to be in our K hat direction, where our magnitude would be Rx minus Fy minus Ry times Fx